So the first part of these notes is just review from the other set of notes. So I just demonstrated that this is an arc length. Feel free to pause this at any point in time if you need to copy these down, because I'm really just going to run through this front page. Example 1 is just like the other video. Gave you a radius, gave you an angle for theta, but it's in degrees. We had to convert it and then plug it into the formula. Same thing here. I don't know if you noticed, but I changed this, and I just realized I went the wrong way. So this example 2 is not correct because it's not 100 degrees. I just rushed through that. It's 360 minus 100. So this is 260. So let me just fix this quickly. This is 260, and then this must be, take off the zeros, divide by 2, 13 over 9. Let me just double check that. 260 divided by 180, and then turn it back into a fraction. 13 over 9 is correct. So this should be a 13, and 4 times 13 is 52. And that's better. That is the correct answer for example 2. We could do it that way, or you can give me the decimal. I guess it depends on what the directions are. All right, next one, example 3. They gave you the arc length and they gave you the radius, asking for theta, both as radians and in degrees. Any one of these forms is fine. Linear speed. Here's the formula. If you watch the other video, you'll see this. V equals omega times r. Angular speed is found this way. Let's flip over to the back. You know what? Let's skip example 5. I was going to do that, but example 6, a 15-inch diameter. So the diameter is equal to 15, therefore the radius is equal to 7.5 inches. And it makes 9.3 revolutions per second. Find the angular speed. So the angular speed is going to be the number of revolutions, which is 9.3 revolutions per second. And we want to multiply that by the conversion I gave you on the other sheet, 2 pi radians over 1 revolution. And then we're going to multiply that out. So that is approximately 18.6 pi radians per second. You could do that out in your calculator, and that is 58.4 radians per second. I didn't specify how to leave your answer, so either one of these would be fine. Find the linear speed in inches per second. So we already have inches, we already have seconds, so we're good to go. V equals the angular speed, which we said was 58.4. We want to multiply that by the radius, which is 7.5. And that's going to give me 438 inches per second. Moving on to example 7, the circular blade on a saw has a diameter of 7.25, so that means the radius is equal to, I think it was 3.625 inches, and rotates 4,800 revolutions per minute. So find the angular speed. So I'm going to take my 4,800, V equals, omega equals revolutions per minute, and I need to multiply that by 2 pi radians per minute. Sorry, I'm trying to hustle because I'm afraid the phone's going to turn off. So now I have 4,800, I think that's 9,600. But did I have to convert something also? Radians per second. So not only do I want to change the revolutions, I also want to multiply by some conversion from minutes to seconds. So I'm going to put minutes on the top so they can cancel out, seconds on the bottom. There's 60 seconds in 1 minute. So I'm going to do those calculations in my calculator, and I am going to get 160 pi, and that is going to be radians per second. And again, you could multiply that and get a decimal. Find the linear speed, so V equals 160 pi radians per second. We're going to go in feet. Too bad. I'm going to have to change that. Times the radius. The radius is 3.625 inches. So I need to convert into feet. So I'm going to multiply by inches, feet. There's 12 inches in 1 foot. So I've got that all set. I'm left with feet on top and seconds on the bottom. Oh, I'm good with that. So now I'm just going to multiply all of the tops together and divide it by the bottom. So 160 pi times 3.625 equals, and then I'm going to divide that by 12, and I get 151.77 feet per second. And last example, example 8. A woman is riding a bicycle whose wheels are 30 inches in diameter, so that means the radius is 15 inches. If the wheels rotate 150 revs per minute, find the speed at which she's traveling in miles per hour. Okay, so we have V equals, we have 150 revs per minute, multiply that by 2 pi radians per revolution. Then we have to multiply that by the radius, which is 15 inches. And we want to convert inches to miles. I don't know if you remember all these conversions. I'm just doing a dimensional analysis, basically. So inches goes to feet, so 12 inches is 1 foot. Then we got to go from feet to miles. I don't know if you guys know, 5280 or 5 tomatoes per mile. So feet, inches, inches. Now we need to get to hour. We have a minute down here. So we're going to put a minute up here and to hour. So it's 60 minutes and 1 hour. And then we're going to throw that into our calculator. Hopefully I didn't forget anything as I'm hustling through. 150 times 2 pi times 15 times 60. And then I'm going to divide that by 12 and hope for the best. I forgot something. Oh, I forgot to divide by the 5 tomatoes. Divided by 5280. And I get 13.4 miles per hour. Done.